actually had like a special lecture on superconductors, but I don't exactly remember everything. But yeah, you get like this levitation where once you reach a velocity, you can just hold that velocity without using any energy at all, which is super broken. The one catch with superconductors is that we don't know how to reach superconductivity at room temperature. So we can make superconductors. It's just really hard. If you there's like this graph that you can search up where it's like conductivity versus temperature, and you see that when you drop below a certain temperatures, some materials go from being like conductive to superconductive. And I don't remember what's the highest temperature that we've reached superconductivity, but it's not that high. And so it's a lot of work to just get to that stage. But that's one of the leading research branches that like piques my interest, because if we do reach superconductivity at room temperature, the things we can do is literally unlimited. Like there's nothing stopping us from, like, the ideas aren't even in my head. That's how crazy it is. It's like
there are a lot of there's a lot of use for superconductors. I mean, you just said the train example. Like that would be crazy. A levitating train. Like that would be so, and that's totally possible, right? Like theoretically speaking, as long as
you just reach like a velocity of like 500 kilometers an hour, and then like you don't need any more energy, and you just hold that velocity all the way through. You can go around the world in like 2 seconds.
So superconductors right now, as you mentioned, they have that critical temperature, right? Ordinary. So we didn't even get into resistance really. So all conductors, all this flow of electrons, there's nothing perfect, right? Life isn't perfect. We know that. The bowling ball isn't perfectly round. The pool ball isn't either. We know this. Effect of reality, right? So the thing is, it's not what was I talking about? Superconductors. Resistance, yes. I fully glitched out there. So electrons, unfortunately, do not move straight through a wire completely impeded, right? They can't, because there's some, and we just spoke about it, but there's no dramatic moment anymore, but there's some resistance, right? All conductors inherently have some resistance, right? This is simply because, well, think about it. If you just had one electron just going straight through the wire, even though I know that's not even close to how it works, that would have zero resistance. But the fact that these electrons are going back and forth between these atoms, right? Now, what happens when you take an atom out? I mean, when you take an electron out, you also ionize the atom. So sometimes when these electrons are just flying all about in these wires and in these conductors, you don't always have a perfect flow. And this is, I don't think there's a fancy term for this. I think it's just called conductor resistance. I don't know if there's any fancy thing for it. But again, all conductors have some sort of resistance, right? Resistance is measured in the famous SI unit of ohms, right? And interestingly enough, for any system that you make, any circuit that you make, you will want to inherently put some resistance into it. Now, this is because too much potential difference, and there could be then there could be a short circuit, right? Which we didn't even get into, where basically the electrons are. So in any situation where we have resistance not high enough, right? That means the electrons are not impeded enough by some material. They can just fly straight through, right? Now, the problem with that is that the object receiving this electron, right? Because usually in any circuit, there's something with the battery, and then there's a light bulb, or there's an object, or there's something that it's connected to, right? So that thing that it's connected to will receive too many electrons at once, an influx of too many electrons, and basically just cut its power out, right? So that's a nice way to think about it, and no one wants that to happen. So even though conductors inherently have resistance is good. It's not bad, right? Because we're talking about superconductors and, oh, it's so amazing when you have zero. It's not bad. Resistance is not bad. You need it, right? Resistance, I mean, if you hook up, anyone who's played with circuits, any circuitry would know you don't put a resistor, you could really mess up your system. So you need resistance. However, in this field where we see, levitating trains and stuff like that, like there is where we could, I believe even in MRIs to actually produce those strong rays, they actually use superconductors. Again, because of the fact that there's no impeded flow, we can have, I'm not going to say infinite power, but I'm going to say a lot more power than we would have had if there was some resistance, right? So that's where resistance plays into it, and it is really important. So just wanted to clarify that even though superconductors are cool, resistance is still important. Wanted to clarify that point.